Hi, welcome to Advanced Analytics with R and SQL. I am Nagesh Pabisetti. I lead the PM function for Microsoft R Server on all the platforms, both on-prem and cloud. And?
Yeah, I'm Tobias Ternström. I'm the GPM for integration of R into SQL Server, as well as SQL Server on Linux. And so today we have hopefully quite an interesting agenda for you guys. We'll start with Nagesh going through the need for intelligent apps and how this intersects with the R language. And for those in the room who don't know R, how many of you guys use R on a daily basis? Okay, just a few. So Nagesh will also give an intro to R so that everyone has some sort of context of the R language. And then we'll go over to look at kind of the combination of SQL and R and what we've done and how you can build better apps.
And in this presentation, I'm going to play data scientist, and I am data scientist on TV. And Tobias?
Yeah, I'll be the developer.
Great. And before we go into how to do advanced analytics with R and SQL, I want to talk a little bit about the why, right? So advanced analytics is the one that powers intelligent applications. You take any application that you have within an enterprise and add advanced analytics to it to make it intelligent. And we believe that we are going to a world where everything is going to be intelligent. Intelligence is going to be ambient. And that's going to be realized through a set of networked devices, cloud power, insights from data, and intelligence from machine learning. And that's the vision that we are all working towards. And we believe that that's the vision that all of Microsoft and all of the industry is going towards. And what we're talking about today is bringing together the most recent launches that we've done, which is about R Server on multiple platforms and SQL within database analytics. How do you combine them to be able to do advanced analytics? And when we talk about insights from data, so everybody has data. It's coming from a world of interconnected devices, our systems, our interactions with click streams. And what we want to be able to do is to be able to make decisions and take actions based on what insights you derive from this data. And previously, or even currently, the way we have been doing it is more about business intelligence, which is more about descriptive analytics, what happened, and diagnostic analytics, which is about why did it happen, and really trying to understand that. But where advanced analytics comes in is more about what is likely to happen based on what I have seen, not only what I have seen in my system, but what has been happening in the world at large, on relevant information from the world at large being brought to bear here. And the last one, which is about really what should I do? And that could be a manual thing that it returns, or it could be automated and built into the application, which is when the application becomes fully intelligent. And that's the way we believe that when we are able to automate this entire process is when we derive the highest value as businesses. And this is not something that we're talking about somewhere into the future on someday that it's going to be possible. It's being done today, and these are just a sample of the customers working with us. So if you take any industry for that matter, there's healthcare, there's manufacturing, there is retail, and then you have marketing, you have operational optimizations. Every field is being touched by advanced analytics. And you already saw the one about Dartmouth Hitchcock and how they're optimizing things so that you don't have too much patient readmissions. To take care of patients while they're at home, monitor their vitals, using that information to be able to predict if something like a heart attack or something like that is going to happen. Think of how much that intelligence is vital to not only the patients and the humans, but also to the business at large, both of these. And you must be wondering, okay, so what do I do, right? So there is, your application has always been there. Now, how do I make that intelligent? It's 3 easy steps. I say easy with tongue in cheek. And the 3 easy steps are: first, if you were to think about it as a marketing application where, let's suppose it is Tobias Bank, and you have multiple accounts with Tobias Bank, you have mortgage with the bank, and you also have an online relationship with the bank. And so he already knows, or this company already knows, a lot of things about you. And so taking that information, which is systems of record, and then you exist in the in the world at large, in the World Wide Web. How are you going to take that information and interactions and combine it with the systems of record, so intent and record being combined? And then I'm sure there is information about me out there with a lot of the data banks, which know my credit score, I know which credit cards I use, where do I go for purchasing various information. Getting all that information, cleaning it up, joining, deduping, and cleaning up, and putting your domain expertise on top of it will help with the preparation phase of it. And that can be done in SQL Server, which is obviously an environment that is optimized for doing data manipulations. And then it is about modeling, which is the world of machine learning and statistics, where you are going to apply the knowledge that you have about me, and you're going to combine that with my behavior over a longer period and be able to draw some conclusions. You will create models, and there is a lot of iteration and exploration because you have to combine the domain knowledge and the data here to be able to extract out which are the features, as we call them, that will be most appropriate for this particular exercise. And then operationalization. Typically what happens is people develop this in a statistical language like S, and then throw it over the wall to a line of business developer who actually translates this and make sure that there is nothing lost in translation, if you will, and be able to then operationalize it. And then if you want to change it, you go through the process all over again, introducing a lot of latency and errors into the system potentially. And so it is important for the system to be able to support you from model to operationalization, and your line of business application really benefiting from it has to happen very quickly. And so how do you do all of this? Especially the middle part is what I'm going to be talking to, because I'm Nagesh, the data scientist. So I'm going to talk about R, the language of analytics. And if you were to look at how prevalent R is today, it's about 36% of people who do BI were polled, and they said that this is their primary tool, and 2/3 of everybody polled said that R is one of the tools that they use for analytics. And if you look at where it is in terms of popularity, it is #1 in terms of special purpose languages, and #6 if you take all of the languages combined. And so it is also, it has been rocketing up. From 2014 to 2015, it has gone up 2 places. And a little bit of history about R. There was S statistical language that was invented in Bell Labs, AT&T. And in the 90s, 2 professors from University of Auckland actually wrote the open source implementation of S, which is called R. And that is governed by the R Foundation. The R Foundation acts as the face of R, and they make sure that the direction of R, the core contributors of R are part of the R Foundation, and they set the direction. Now, the R consortium, of which Microsoft is a member, actually guides the R Foundation, and also it makes sure that R is widely used in the industry. So best practices, funding certain projects so that it makes R more useful, usable, and adopted in a wide manner are the things that our consortium does. And the power of R, I mean, it's not just the language. That's a fairly simple language. I mean, it has all the built-in functions for statistics, and I've peppered the whole presentation with a lot of links for you to go check it out later. Similarly, whenever I show source code, there is probably 1 to 5 times the number of source lines. I have comment lines to actually help you understand what is going on, and a lot of references peppered even in the source code so that you can go check it out when you get access to it. I'll tell you how to get access. And so there are the number of packages that are being developed by in the open source community by the developers at large is skyrocketing. If you were to look at just the last 2 years, 3,000 packages were contributed into the open source. And each package is not just single algorithm. It's a package of algorithms. So think of the power that you have. And if you were to think about your day jobs, and you look at just one screenful of these packages, you will see that irrespective of what role you play and what vertical industry, there are algorithms already in the given as packages for R in CRAN libraries. And this is only one of the libraries. You have on GitHub, you have on Bioconductor. So there is several other repositories of algorithms. So really, while doing data science, you have to combine domain knowledge, you have to combine statistics, machine learning, and lot of patience and iteration to be able to arrive at the right model. Because in the end, it is only a few lines of code, you will see. But to come up with it, it takes a lot of effort to be able to optimize. And what we did is we want to leverage everything that's happening in the open source community, be it the language, be it all the packages that are being contributed. So we created another set that actually is a package called RevoScalar that works along with everything that is happening so that you don't have to change a thing if you're developing, if you already have an install base of R. You can use Microsoft R Server, and what it provides you is that it provides you really enterprise scale in terms of size of data. It's not limited to what fits in physical memory. Second, it can take chunk data out of your disk, and it can stream and feel as if it is one contiguous whole. And you can have it run distributed transparently on a cluster of processors and nodes. It runs on a variety of platforms. As you can see, it runs on databases. It runs on RDB, relational databases, in database with SQL Server and Teradata. It runs on Hadoop, all 3 versions of Hadoop. It runs in the cloud. We just announced running on HD Insight along with Spark just a few days ago at Strata. And of course, you have it available as VMs. And most importantly, what we are actually doing is to make sure that the language feels native to the natives. So we provide tools, we provide all the support so that if you're a SQL developer, it feels like you are doing R, yes, but you're doing it in the tools like Visual Studio, SSMS, SSIS, all the tools that you are very much familiar with. We actually make sure that this works so that it appears to you that the whole world is being brought to you as just a single feature that's new coming in. That makes it easy to be able to understand, adopt, because you don't need to really do new tool sets. And there is a lot of information about what really happens, and Visual Studio is a key aspect of this whole product suite that is delivered from Microsoft for R. So let's, enough of PowerPoint. Let's go and take a look at some code. All right, this is, as you know, Visual Studio. You can see that, right? Microsoft Visual Studio. What is different is that you have a set of menus under R Tools where you can, you have all the things that will allow you to play with R and develop in R. And I would, when please do go get this R Tools for Visual Studio and install it. And then you can go to RTVS documentation and samples. And you will see not only this sample that I'm showing you, but there is a ton of samples, and we are constantly adding it with a lot of documentation so that you really understand what is going on. I'm going to actually walk you through just one of those examples, and this happens to be about diamonds. So there are multiple factors that go into the price of a diamond. So what we're going to do is actually show you how you can read data, be able to use those, obviously the dependent variable is price here, and the independent variables are multiple that you will play with, be able to come up with a model, and then be able to use data to be able to come up with, using that model, what does the prediction come from, and then look at what's the difference between what the actual was and what the predicted value is. So it's essentially the complete process in just one program. So the first one I want to show you is a library that what is it? I want to show you, for example, install packages. This tells you, I told you that everything is the world of packages. So you do install packages. It tells you all the packages that are on this machine, because typically a programmer won't know what is on there. And then you do search, and this tells you what has been loaded onto this program, so that that is available to this program, to this R script. And when you go to, for example, this is, you're loading a library called foreign, and then when you search, you will see that now foreign is available to this program. So what you've done is you've loaded it.
So this is similar to SSMS with an interactive mode, where you can just execute kind of things step by step.
And then we are going to actually use ggplot, which is a graphical package that is available with available in CRAN. So we're going to load that, and it just says that the version is mismatched. That's okay. And then now when you do again library, and you will be able to see that package. And what is interesting is that ggplot, the package, also comes with a lot of data, and it so happens that that diamonds is a data set that is included. See how convenient it is? It's not only giving you just the plot library that you would have in multiple high-level languages, but it's also giving you data sets so that you can kind of experiment with it, understand it, and then be able to use it on a lateral world where you are using it in your typical application. So now we are reading data from the diamonds package, from ggplot package. This is diamonds data. And if you look at what's the structure, this is very interesting. So if you look at it, it is a table, and it has multiple fields: caret, cut, color, clarity, depth, table, price, and so on. And it also says what kind it is. It's a numerical or an ordinal factor. That means it is not only a factor, but there is an order. So fair is less than good, and so on. And there are, how many levels there are, with 5 levels, 7 levels, 8 levels is what the world of diamonds looks like is. And then you can always list the top few rows, and similarly tail and class and dimension is telling you, how many rows and how many columns. So there are 54,000 rows, give or take, and then 10 columns. Now let's see what this data looks like. Let's plot it. Oh, so first of all, you know what? I'm not taking all of the 50,000. I'm going to take a sample of 5,000 rows, and then start plotting this. And first, let's see. I just want to plot. I just want to plot and see. Okay, so if I were to say caret weight and price. It's not a great relationship between these two. I mean, there's a high level of dispersion, although I see kind of the startings of some pattern. And now let's suppose that, okay, I say, let's take a logarithm of caret and see how it connects with price, or correlates with price.
So this plotting deal is that's a pretty big deal in R.
Right. So now it is a little better. I mean, you are starting to see things coalesce. Now let's take a look at, if I were to make both price and caret, which are both in log scale, it looks like now you have a nice line, through this data. So it looks like, okay, so I could do a linear regression with log of price being the dependent variable, and log of caret being the independent variable, and then dot essentially says that use the other things also that I have. To be able to use it in the regression, and the data is the diamond sample data, which is essentially 5,000 rows. So let's run that. So you're done with the modeling. Now, let's see. Is this model good enough, or does it seem like it's a good model? All right, that line seems like it is a good regression line, a linear regression. And for the statisticians amongst us, like Tobias. Who studied statistics in grade school. Let's see how it looks. And so if you were to look at how good of a fit it is, it shows that essentially that the QQ plot, for example, if this is really linear, it just shows that the residuals are normally distributed, which means that it is a really good fit. So the model looks pretty good. Now let's take a look at what is in the model. So the model actually has a lot of information, because this is the model that you'll pass around if you want to operationalize the model. So it essentially says that it is a linear regression, and this is the formula that we supplied it. And here are the residuals, essentially the distribution of the residuals in quartiles, all the coefficients and standard errors of these coefficients. And these stars essentially show how well this variable is able to explain the dependent variable. So that means clarity is able to explain a lot of price. So there is a lot of correlation between those two. And similarly here, between color, L and Q, they seem to be able to explain the price a lot. And then you have the adjusted R square, which is 0.983, which almost like it is 98.3% fit, and a low p-value, all those showing that it is a really good distribution, really good fit. And now let's take a look at, all right, let's start predicting using the same information that we have, because we had a lot of rows. Now we'll use our model and say, I'll give you all the rest of the rows. Now tell me what the price would be, right, using the model. And then let us see how the dispersion is. If you look at the dispersion between the model and also the actuals, you see that it is able to explain the price pretty good in the initial stages while the price is lower. But as the price gets higher, it's not, as the carat weight gets higher, you're not able to actually explain that as well. But nevertheless, it's still essentially showing you from end to end how the model actually works.
So the model is like a little program.
Right. And then what we have done is we've taken all of this. So you just saw that R as a language is giving you a lot of statistical and machine learning power along with these packages. We have extended it so that you're able to really use it in multi-node setting, in a cloud setting, in a variety of operating environments, be it in databases or workstations or clusters or the cloud. And then we have given you a set of tooling to be able to make it easy to start. We'll continue to add to it to be able to make it much easier. And then now what we've done is taken all of that secret sauce and essentially put it within the SQL Server. And that's why we started with R and then now going into SQL plus R. And Tobias will talk about what we're doing there.
Thank you, Nagesh. Yeah, so I don't know anything about statistics. And Nagesh keeps reminding me of this. So we're going to look at, once we have this R language, why would you integrate it into SQL and what can you actually do with it? So first of all, this intelligent applications, it's a lot, like Nagesh mentioned, it's a lot about making an existing app intelligent, right? So it's not about you have to build some net new application and follow some net new pattern in order to derive value from this. And that is one of the big reasons we put it inside SQL Server. The other big reason for putting it inside SQL Server is the fact that you typically want to move compute to data rather than the other way around, right? So anyway, if you're building an intelligent application, we say that there are three kind of key pieces to an intelligent application, or to an architecture that you can build on to have an intelligent application. So one of the things is you need to be able to kind of ingest all of the relevant data in real time. So whatever data, by relevant, I mean whatever data you need for your modeling or to make decisions on, you need that available. And you need it available as soon as possible, right? Otherwise, you get much more into hindsight than prediction, right? If it takes you 24 hours to load data, for example. And obviously, you need all of this relevant data to be available in real time, meaning I just got some sensor data from a sensor, landed in my database, or I got a transaction just landed. Well, I may want to compare this transaction or this sensor data with data from an hour ago, from a month ago, or from a year ago, right? And I need to be able to do that quickly. So you also want the query capabilities across this data. And then finally, you want to be able to apply analytics to this without having to move the data somewhere else, because that kind of defeats the real-time nature of the problem. So these, we say, are 3 key factors to build an intelligent app. And if you look at this picture that Nagesh showed earlier, really preparing data from a SQL perspective, if you're already in SQL, well, that's a query, right? You write a query that gets, for example, this diamond set that might be joining a bunch of tables, running some aggregations or something, and that result set is what you will use to build your model and to predict. Then you have the data science piece, the modeling, and then finally you operationalize by moving this into the database. And this final step of operationalization was really a big problem, meaning you used to build, so the data scientist spent a bunch of time understanding the data, plotting, etc., right? Finally, when they understood the data, they build a model. But then, from the time that they had the model built, they now have to hand this model, this little program, to a developer that needs to translate that into C#, Java, C++, pick your poison, right? Which obviously is a very slow process. So you can't really update the model continuously. You'll probably have to say, okay, we'll build the model today, we'll use this model for the next year. Next year we'll build a new model, versus maybe training the model every week, every hour, or something like that. So you obviously want the model to keep getting smarter based on new data. To handle this real-time aspect of the problem, we have very, very good support for something that Gartner calls HTAP in the latest version of SQL Server 2016. So HTAP is the new fancy term. We have OLTP, which is online transaction processing. We have OLAP, online analytical processing. HTAP is basically saying, hey, why don't we just run those together? So that's hybrid transactional analytical processing. And SQL Server has support for basically 3 ways to store data, right? We have a traditional row store, which is, how many in here use SQL Server today? No, almost
okay,
a
awesome.
couple of you. Very good. So the traditional row store. We also now built a column store that started in SQL Server 2012. We're now at version 3 of the column store. And we're at version 2 of our in-memory row store. And let me talk just briefly about this in-memory row store, because that's a pretty big deal. And it's a huge update in SQL Server 2016. There's a lot more you can do with the row store in terms of functionality versus SQL Server 2014. And the problem we have in databases is everything, in more or less all database engines, everything is optimized for very slow hard drives, right? So what do we mean by this? Well, a hard drive, a very good SSD, let's say, has response time in the low milliseconds, right? Maybe even less than a millisecond. Meaning if I ask it for something, I do an I/O request, it will take it roughly a millisecond to find that data for me. And people say, oh, this is fabulous. Well, main memory has a lookup time in the low 2-digit nanoseconds. And if you just think about the difference there, there's 1,000 milliseconds to a second, right? There's 1 million microseconds to a second, and there's 1 billion nanoseconds to a second. So we're talking a difference of hundreds of thousands of times between what a hard drive can do and main memory can do. So everything is kind of optimized for this very, very slow thing because of the fact that it has, one thing is durability, right? If I store it on a hard drive, hopefully I don't lose it. And the other thing is that main memory used to be very expensive, right? And it's obviously getting lower and lower cost. So the in-memory engine is basically saying, hey, let's instead store the data in main memory and only use the hard drive for the transaction log. So we do some snapshotting or checkpointing to the hard drive and transaction log. But all of the main data is all in main memory, meaning we use main memory structures like pointers and such versus trying to build pages and extents and so on, which is a huge difference in performance. The other thing that we do is that you can create procedures and have them be main memory optimized. That means instead of it being interpreted like regular SQL, meaning we have an execution plan, we run through it, if this goes that direction, right? Instead, once we have an execution plan in the stored procedure against main memory tables, what we'll do is we'll generate C++ code, right? We'll do code generation, we'll use the C compiler to build a library, basically, and then load that into memory and use that. So now it's not interpreted code anymore, it's natively compiled code. And that's how you can get differences in performance up to 30 to 50x, right? So that's what, 3,000 to 5,000% faster. The downside of main memory optimized tables is that they have to sit in memory, right? So if you need to keep a lot of data there, it may not be possible, right? So that's why we have our column store. And the column store is basically storing things, instead of row by row, it stores column by column. So it says, Tobias, 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 Nagesh, and so on. Given that you store things column by column, obviously if I say select some price, it only needs to read the price, right? It never needs to read any other columns because it can just access the price column. The other thing is if you store things column by column, it's the same domain, it's very easy to do very efficient compression, right? Oh, I have 5 things with the price 10, I'll just store 10 times 5, right? So column stores are very, very efficient for analytical queries. Now, what we've done in SQL Server 2016 is that we actually allow these to sit on the same table, right? So one is you can create a column store on a table, you can create an in-memory OLTP table, but you can also have the same table use both, okay? So this means that you can derive value from the column store for your analytical queries, while you derive value from the in-memory row store for high-speed ingest. But accessing the tables is still just regular SQL. So let's jump into a demo and look at this. First of all, some context. So for this application, we're pretending we have some e-commerce app because it's an easy, kind of common scenario. We have it's like me and Nagesh, very good businessmen, so it's going really, really well. We're selling lots and lots. So we have tons of shopping baskets being created. We have tons of orders being created from the shopping baskets. And we have a latency requirement of no more than 10 milliseconds to submit an order. The problem statement is we also have an issue with customers returning products, right? Meaning that we have lots of customers, they buy something, and then they look at it at home, right? I'm sure some people in here have done that, and then they just return it. So we want to be able to predict if customers are likely to do this, and if they are, we want to basically have them call our, instead of just filing the order online, we want them to call in so that we can check whether or not we should actually take in their order. So kind of common problem, and that's the intelligence part here. So this is kind of the user experience of the application. It's written in PowerPoint, so very good. Yeah. Joseph is our boss. So he sits on the board of Nagesh and Tobias Corporation. And you can see here down there to the right that once you submit the order, it just says thank you. And this is what we want to change, so that if we predict a customer is actually likely to return, we instead want to show an error or a message there saying, hey, you have to call us, right? And I obviously don't want to show that to all customers. I only want to show that to customers with a high risk of returning, right? So the setup is simple. Instead of this web application, we have a simple workload generator. So I'll show that we basically have one thread, gets one database connection, and that thread will sit and basically insert orders, okay? And the database is based on the TPC-H schema. So if anyone has looked at that schema, it's a very simple kind of customers, orders, inventory, and so on. And then from the database perspective, this is kind of what it looks like. So we have shopping carts getting created, and those go into orders incoming and line item incoming tables. And those tables are main memory optimized. I'll show you all of the code. Then, once they submit the order, then apparently order status S, those get moved into the order and line item tables, because that's submitted orders versus shopping baskets. And then we also have a table where we store our models. So remember the model that Nagesh created. That model is basically a little program, and from an integration perspective, it's just a var binary max, right, that we store. So now what we want to do is we want to get the app from this before picture to with intelligence saying, okay, this is a suspicious customer, you have to call us to make the order versus just submit it online.
And then we'll give you some tender loving care.
Yes, Nagesh will take care of that. So let's jump in and take a look. So first of all, just from a schema perspective, what the table looks like. So I have my little build demo database here. Everything is running on my laptop. We use the big int data type instead of integer. That's the minor change from the TPCH schema. So first, let's just make sure that the tables are empty. And first of all, so the orders table and the line items table, those I use this hybrid approach. And I do something interesting. So the table itself is a regular clustered index. So that's a regular row store, disk-based row store. This is where I have to store everything. Now, in order to get my analytics quick, I want a column store on that table. Okay? But I don't want the column store on the entire table. I don't want the column store on the latest data, because I want to be able to ingest even into this table very quickly. So the thought is the shopping baskets, the incoming tables, those get lots and lots and lots of inserts. And then the regular orders and line item tables get less, since that's only the submissions, right? So here I say create this non-clustered column store index, which I clearly didn't say. There we go. Now it's a column store index. Anyways, on this table, but only include order status not submitted. So once they go further in the processing, they get some other order status. Only those will be included in the column store. And I do the same thing for the line item table. Here is one little sneaky thing, is that I had to add the order status column denormalization to the line items table, right? So I know also for the line items which ones I should keep in the column store versus not. Okay. So next, let's look at the shopping baskets. So here I have the order incoming table, and the only real special thing here is the bottom, where I say memory optimized on, and we have two settings for this. Either durability schema only, which means we don't flash anything to disk, right? So if you restart the service, you lose the data. That can actually be very, very useful. There's lots of kind of transient data that walks through your app where you don't want to pay the cost of sending it to disk. So that's something that's very useful to say schema only. But for this, obviously, I want to keep it, so I say schema and data. There's another interesting feature in SQL Server you may not know about, which is we support, starting with the previous version, delayed durability. So you can actually start a transaction and say, hey, for this transaction, you don't need to flush when I commit. I'm OK with some more inconsistency here because I want the speed to be higher, right? So we're starting to kind of integrate more and more ways for you to basically change the ACID properties if you need to. But remember, in the same database, I can have lots of things are strict ACID, some other things are not as strict, right? Depending on my performance versus functional requirements. So I have that table. The line item table looks almost the same, but I have a foreign key here to the incoming table, right? So it's a regular relational database, right? And we see the primary key is over these two columns. Then I also have a table type. So this is for me to handle a high degree of inserts. When the web application actually inserts the data, it will call into a stored procedure and will pass the order as parameters, but it will pass the line items as a table parameter, right? So it can pass lots of line items in one call versus have to make multiple calls for the line items. So that's the definition of that. That table we will cover later. So then we have the stored procedure here. So here you can see I pass in the columns or the parameters needed to create an order, plus this new line items, which is the line items that I want to insert with the order. And then you can see here with native compilation. So this is one of these natively compiled stored procedures. They will generate C++ code, call C++ compiler, and so on. And then you can see here we insert into the orders incoming table, and then we insert into line item incoming with a select from @new line items, which is the line items that were added to this order. And that's basically the stored procedure. OK. So let's now take a look at the application. So the application is a simple workload generator. So I can easily kind of add and remove threads and connections. And it will do And each thread has basically a loop that it continues to do something. And it does basically two things. One is run, basically add the order, which is this method. The other thing is for the first thread, so only one thread, I will run a cleanup query every so often. You'll see that. So that cleanup query will basically remove old orders, right? Or old shopping baskets I don't want to keep around.
Incomplete.
And exactly, incomplete. And transition those, the submitted orders into the orders table. So here you can see where I build up the command. So we create just a regular SQL command, assign the parameters, and then also here we add the line items. So the line items, I use the SQL DB type structured. And then the cleanup script you can see here. So that's just inserting the orders over to the orders table with a delete with output for order and line items. Okay. So let's start this. So now we have one thread running, and let's first see, and you can see at the bottom there, it's how much pacing we're doing. So within the loop, we're waiting 100 milliseconds for each insert. So let's just bring that to 0. So now you can see at the top here, we're inserting around 13,000 rows per second, which is pretty good. If we add another couple of threads, we bring this on my laptop now to between 60 and 80,000 rows per second. That's pretty magnificent for, 4-core laptop with hyperthreading. And remember now, it goes into the line items tables, order table, incoming, and then moves over to orders and line items. So we can see here, I query the 4 tables. If I keep querying, you can see here that the upper tables kind of get reduced in number every so often. That's this script that moves the data over to the other tables. And you can see that the bottom 2 keep increasing. So we see that it's working. So now let me just bring this to a more normal rhythm. We'll say 150 milliseconds per thing, and add a few more threads. There we go. So now this is running. Now we want to add this intelligence. And let me just show you the query that we're going to use, and then we'll go over to Nagesh and see how we actually go and do the intelligence or the advanced analytics over this query. So I have a view here, and that's the view that Nagesh, the data scientist, is going to use. So you can see here, we query the orders and line items table, and basically calculate a couple of things. So number of orders with F status, number of orders with O status, P status, number of returns, number of ship returns. And then we also say here, and this is what we want Nagesh to go predict for us. We say, hey, if someone returned more than 30 items, we think that's bad. Okay? So we want Nagesh to try to find the correlation between C_return column and the rest of the columns, and use that to build the model. Okay? And this is the example of SQL is great for this, right? Generating this, processing this data over the column store, over the in-memory row store, and then you use R for the modeling. So let me also pause so we don't fill up. So I'll just pause the workload while Nagesh shows us this.
So what we have to do right now is I have to develop, as the data scientist, I have to develop models based on the information that Tobias is giving me from his database. So I have a list of fields from which I'm able to take those as independent variables and be able to have the dependent variable, which is essentially likelihood of returning, right? And create a model with that information and then use that to predict it. So this package is essentially RevoScaler R, which is the package that I talked about called Microsoft R Server, everything embodied in one library. So I require that. Then I know that I have to get this information from a SQL database. By the way, a SQL database is installed on my laptop, and that's where I'm getting this information from. And next thing that is really interesting about the Microsoft R Server is the fact that there is this concept of remote compute context. So you are on a local workstation, and you're working, right there, writing the scripts and having the development environment, but you know the data is actually on a database, you can actually develop the script here and say, execute in DB on the remote database, and that is called remote compute context. And that's something that is unique to Microsoft R Server. And that's what we just set here, saying Rx set remote compute context by giving all the parameters that we've just seen. Then you essentially, I'm taking the top 10,000 rows, and then using that as training data and constructing this. This is essentially constructing that C return is the dependent variable, and all of these are the independent variables for the model. That's the syntax. And I'm going to generate a model which is a random forest classification model. And I'm trying to essentially say, OK, give me information as it executes, start with a seed of 5, do 3 trials, construct essentially 20 trees with maximum depth of 32. And when I say 3 tries, it essentially says randomly take 3 independent variables and try to figure out how to actually branch out in the random forest. So that's essentially what it is doing as creating the model for classification. And then it gives out the model. Once it's done, it's working. I mean, I don't have as many cores as Tobias has. It's my regular work laptop. And now it is done creating the model. And the way you actually ship the model to for operationalization is you actually serialize it. So once you serialize it, I can give it, and it can be as a blob within SQL. And length is just a command that says how long, how big it is. Now, typically what you would do is I created this model. I would hand over to I would store it in the SQL database. And then for operationalization, we'll see what Tobias does in a few minutes. But before that, I want to also show you how you use this for predicting. So as the transactions come in that Tobias showed you, one by one will need to be scored. And for existing customers, we're saying we'll score every hour. And for new customers coming in, we'll score as the people come in. So essentially, that's a optimization that we've done. And also, I want to show you how you use local compute context, just as an example, right? So that you're able to do the same thing, same script. The stuff is executing now locally when I do this. I mean, locally as in right within my, no, it's not going to SQL Server. It's executing right on my laptop.
So I can choose if I use a remote compute context or a local compute context.
Right. So let's say I do that. One moment.
I just hit escape.
OK. Unserialize the model. That's the first thing you would do. And then essentially do Rx predict. And you're saying, OK, if the likelihood is above a threshold of 0.81, essentially 81% likely for that person to return, then you actually replace what value is there in the data with essentially whether it is a 1 or a 0. So now let's see, using that information, let's see if I can look at what the return customers, how many return customers there are. It looks like in the sample that I took of like 10,000, there are 122 observations where there is more than 81% likelihood of this person returning stuff. This is showing essentially the prediction is saying 1 because we said if it is above 81%, replace this prediction column with 1. And that is the scoring part. So you have the creation of the model and the scoring. Then I develop these as the data scientist and give it to Mr. Developer, and he'll show the magic what he does with it.
Thank you, Nagesh. So let's turn on the workload again to unpause it. And this is just to show that we're doing this operationalization in the actual server, right? It's not some separate data warehouse or something where you're moving the data over and then doing your model training and prediction. We're doing it in database, in the operational production system. So let's move over here. And here I have the table where I will store the models, first of all. And you can see the model, we have a name of the model, we have the actual model, which is just var binary max, and then when the model was created. And obviously, it's a good thing if you operationalize models and keep adding them or updating them. You probably want to keep the old model if you run into trouble, right? So here now I have a script to actually do exactly what Nagesh did when he went and trained the model. So he basically gave me the exact R script and said, Tobias, please operationalize this R script to train the model. And this is something that you would probably schedule to run, I don't know, every week, every day, every hour, whatever kind of works for you, however often you want to refresh the model.
And what is very unique about this is that I told you about operationalization and the delay generally is there. That delay is no longer there. All he has to have time for is cut and paste.
Right. Oh, it takes a while too. So I start this training of the model, and now let's look at what's happening. So I pass in, this is the query. I'm taking all of the rows in this view, and that view returns around 100,000 rows. So it's one row per customer with all of these attributes, number of F orders, returns, and so on. And then this, we have this new stored procedure, SP execute external script. So right now it only supports R, but that basically says, hey, I want to run this R script. You have to have permission to run it. There's all sorts of securables around this. But if I have permission to run it, then I can pass in the actual R script. So this is exactly what Nagesh used. And you can see that's just the text, right? And then you can see down here, one is we can pass in an actual data set. We'll see that in the next example. So here I'm not passing in anything. What I am passing in is a bunch of parameters. So I want this model to come out. So I have an output parameter to actually fetch the model from the R script that was generated. And I pass in the instance and database name so that it can connect back and the actual query to run. So you can see here I pass in those parameters, and there I fetch the model. And now it's done. So it trained the model in 43 seconds and basically inserted it into the models table. So we can just take a look in that table. So you can see there is the model, okay? So now what if I want to use this for scoring? Well, then we need that other script that Nagesh was working on. And in this case, I'll create a stored procedure to use it, also so that you can see that from an application perspective, it's just connecting to SQL Server over TDS, executing scripts, right? Batches or calling a stored procedure. So from an application perspective, there's no hosting of R or thinking about R. It's just a SQL script. So this procedure basically takes the model name in. I just make it the default, the model I just generated. This threshold that Nagesh was talking about, so apparently if it's over 80%, we think the risk of this customer being likely to return products, we'll say that that customer is high risk. And then we can also pass in which customer to score. So remember, I want to score all customers every now and then, right? And I want to score new customers individually. And this is basically an optimization. So we do very, very well at scoring a large amount of roads, batch scoring. And it's a bit slower to score individually. So if you score individually, you're talking maybe a couple of 100 milliseconds to do a score, right? So in this procedure, you can see basically the script that Nagesh gave me. In this case, we pass in this query. So if you supply the customer ID, I just get the parameters for that customer. We pass in that data set into a data frame. So you can see that's the query. It's going to appear in R in a data frame called pred_base. And then we want to take whatever is in the data frame pred_result and return that out in SQL. So you can see here, pred_result gets the actual prediction at the end. And then we specify that this actually returns these three columns in the SQL world. So customer ID, probability, and the prediction based on this threshold. So let's just create that. And this is still running, right? So we'll predict this customer who has apparently a high likelihood of return. Right now, I just loaded the model right from this models table. I ran that R script in R. I loaded Microsoft R server and got the prediction. So all of that happened there. And apparently this other, if I load both of these, this other one has a low risk of returns. And if I run it without parameters, now I'm scoring all my 100,000 or so customers. And let's see what that comes back. There we go. So like 11 seconds, and we scored 105,000 customers using this model that we just created. And obviously here you could do an insert select, right? Or so insert execute. So you can insert this result into a table or into a table variable, and then maybe update a column based on this result. And then let's pause the workload again. So this is just something showing you roughly what happened here. So when Nagesh was working on his laptop, he went through the R interpreter went through the R script as he was hitting Control-Enter in the IDE in this case. Once it hit this remote, this RX function that actually uses this remote execution capabilities, then his workstation actually contacted SQL Server and said, hey, I want to remote this function. Please run this query, please train this model, and then give me the results back. So it doesn't have to move all of the data from the server to the workstation in order to do this training. And then if you look at the second slide here, it's what the application did. So in that case, the application just connects to SQL Server, and it runs all of the R scripts and trains the model, scoring, etc., inside SQL Server, right? So it never calls out to anything but obviously R on the same machine. And we host R in separate processes and manage the security of R. So even if you do something crazy in your R script, it's not going to affect your application, right?
And so I told you guys it's very easy, 3 simple steps. In just a span of 50 minutes, not even that, we've essentially learned R, we've learned what data science is, we've learned what how to actually model an application and be able to operationalize it in SQL and be able to build a retail application and score the number of returns. See, it's very easy, 3 easy steps. So really, to net it out, some of the key things that would like you to take away from this discussion is that, first of all, this is a new computing paradigm where you're taking compute to the data as opposed to moving data here, because then you have security, latency, redundancy, out of sync with the main data and the like. Next is that operationalizing models is not this 4 or 5 months translation experience, but it is a simple experience of taking the script that you modeled and operationalizing it within the SQL Server. And last but not least, enterprise performance and scale. So with Microsoft R Server, what you're getting is this enterprise class, which is multiple operational environments, size of data larger than that fits in physical memory, and ability to work in clustered environments and in the cloud. That's what you're getting along with all the tooling. So really, SQL Server R Services is giving you a more comprehensive and complete solution for the whole end-to-end process of making your applications intelligent. And this is not something that's just limited to one application. Just if you look at everything that you're doing, you will be able to identify nuggets where there is opportunity to be able to apply intelligence. It is not the whole application. You take a business problem, returns, a particular problem of what credit card offer should I show, what message should I show, when is the right time that you should be able to show it, or what is the channel by which I want to be able to deliver this. Each of these is an opportunity to be able to add intelligence to your application, and it's not just one whole thing that you have to add intelligence to. And so now that you know all this, what's stopping you? I mean, it's really simple, and there are a lot of links, and the first call to action I would say is please download R Tools for Visual Studio, because that gives you a lot of sample scripts and documentation for you to come up to speed, and also a lot of links. It is rich with links, both our deck and the program or the script, R script. Use it, and that will give you a good launch point into this new world of advanced analytics. And there is several other links that could be very helpful to you. Thank you.
Thank you.